Good afternoon friends, myself Dr. Kushal Bhattacharya. Today I should be discussing on sliding mesh gearbox. In the previous problem we have discussed that the requirement of the gearbox, and as because for different road condition or the gradient conditions the different torque requirement also varies. Torque attractive force also varies, and we have seen from my previous lecture that the first gear will provide the maximum amount of torque, then the second gear, and then the top gear. So what happened when as we increase the number of gears, that is as we moving towards the top gear, the tractive force literally comes downwards, and what happens, the speed, we could get the speed, and we have shown that how for different gradients, in some gradients we can never move in top gears. We have to go for the first gears to get a huge number of tractive force, huge value of tractive force. Now we should discuss the sliding mesh gearbox and how the sliding mesh gearbox works. And if once a sliding mesh gearbox works, you could understand the other gearbox are very easy to understand. There is no problem for that. Now we should go for the sliding mesh gearbox. Now you show, then we see that the sliding mesh gearbox, it looks like this. So here you could see that here the power is coming from the flywheel or the engine flywheel to the clutch shaft. From the engine flywheel the power comes to the clutch shaft. From the engine flywheel the power comes to the clutch shaft, as we have seen in the blue color. The engine flywheel the power comes to the clutch shaft, and the clutch shaft, it is connected with the which is connected with the lay shaft, So and as the lay shaft, all the gears are connected in the lay shaft, and as all the gears are connected in the lay shaft, what happens, as all the gears as the power is coming, all the gears along with the lay shafts are in motion, total motion. And you could see this is the 3-speed gearbox. Where you could see this is the first gear, this is the second gear, corresponding to the high-speed gear is also provided, So this is the first gear, this is the high-speed gear, and this is the first gear, this is the, you get the second gear and the top gear, and the last one is the reverse gear. So it is a 3-speed gearbox. The arrangement is there. So here the car is in the neutral condition. Why neutral condition I have explained. Here the power comes from here, from the clutch shaft, it will go to the lay shaft, and it is considered the main shaft, and it's go to the lay shaft. And as because no power, no gear has been connected with any other shaft, any other gears of the main shaft, so power is not transmitted. That means power has come and it has been localized. Within the transmission system. That is, the power is not flowing out, because what happens, the main shaft is not moving. The power mainly moves from the main shaft. As the main shaft is not connected, so the car can be considered as in neutral position, as but the engine is operating, the clutch is operating, and all the lay shafts along with the gears are in constant operation, are constantly moving. So now what happens when now the first condition, that is the first condition with that is the first gear, how to get the first gear. Now when we move this, now what happened when we move this, suppose the speed coming in the over here is n. The speed coming over here, that is the input speed is Ni. We consider the input speed is Ni. Now what happens, the speed comes in Ni, and now what happens when you engage, when we engage that, what we basically get is that when we engage this one with this one, so let it, for the example, we take it as the A1, and this is considered as the A2. This is considered as the no, for example, if we consider the number of teeth for this, is if you consider as A, if you consider as B, and if you consider as C, and if you consider as D, and if you consider the top gear as E. So these are the number of teeth in different gears. Now what happens, basically what happens when we require a first gear, so what happens, there is a motion which could be giving in the x direction, because a sliding motion can be given on the shaft, because you could see a sliding motion can be given on the main shaft. So what happened, it could be changed, in any direction along the x-axis, either left or right, depending on the requirement. So when we move the gear, the first gear in this direction, so what happens, so then power starts to flow in the first gear. So that has been shown over here. When we engage this when we engage this, so let us take the input speed Ni. Let us take as the input speed Ni. So what happened when it is connected? So what happens? The gear power moves from here and it comes from here to here. That is, it will move from this direction to this direction. That is the first gear. So what happens? If you could see that, if you consider the input speed Ni, and the input speed is coming over here. Now if we this is considered as Na, if you consider as NATA, we know that Na and Ta is the number of teeth, or Na if you consider as Za, that is Z is represent the number of teeth. NaZa is equals to NC ZC. NaZa is equals to NC-ZC. Now Na is basically the power which is inputted to you. So if you calculate from here, you will get Na is equals to Na, what is the power transmitted, that is the output, that is the NC from here. NC is equals to Na into Za by Na into Za by Zc. That is, if you could see this, from this diagram, it is NaZa is equals to NC-ZC. So NC is the output speed. So NC is the output speed. When you get the answer output speed, NC becomes equals to, this becomes a dirty. So if I write it properly, if you get a NC, if you want to get the value of the NC, so just change the equation. We should get the value of NC like this. It will get NC equals to NaZa by NaZa by Zc. Now we could see that the Zc, the number of gears, Zc is Za. In comparison to Za, Zc is much higher. So over here we could see the number of teeth is also depend on the diameter of the gear. So Zc is much higher than comparison to Za. So what happens? The Nc will be lowered in comparison to Na, because the Zc, this factor is much greater. Zc is much greater. You could see that Zc is much greater than Za. So what happens? The power will be reduced. So that is the main function of the top gear. That is to get a reduced power, but you get a high tractive force. So if you recall what I've explained previously over the speed versus tractive force, So you see, this is the top gear, then comes the second gear, and then so this is the first gear number 1, this is the gear number 2, and this is the gear number 3, or the top gear. So as we go to the higher speed gears, as we shift to the higher speed gears, so we get less amount of torque, because the top gear will get a higher torque, the second gear will get a lower torque, and the third gear will get more lower torque. So I have explained this in my previous lecture. So what happens, because the number of teeth are reduced, so we will get a lower torque over here. Now when we go for the second gear, arrangement, we basically, what we should do, we should shift this gear in this direction. So when we shift this gear in this direction, what is the case happens? Now power flows from here, the clutch gear, and when it is engaged with this, the power has this direction, the power gets this direction of the second gear, and it moves like this, and it moves with this, and all other gears remains moves, but as it is connected to the second gear, the power will move in the second gear. And what will happen for the third gear, or for the top gear, what will happen for the top gear? This one is a top gear, so it is connects directly. So what will happen in the top gear is that when you place it in the top gear, so power will directly, whatever power is coming to the input, it will move directly to the output. That is the output of the transmission system, transmission component. So whatever power has been produced by engine has been transmitted to the vehicle, considering the mechanical losses, but total power is lost. That means you are going for a top gear, we are going for a high speed. This one, you are going for a top gear, that is we are going for the high speed. Now what happens? You are going for another type of gear, that is the reverse gear arrangement. Now basically reverse gear arrangement is attached with the first gear, so this is a reverse gear. So when reverse gear arrangement is there, we require idle gear. So what is the function? Basically function of the idle gear, if you recall, what is the function of the idle gear is provided. That means if this gear in the layer shaft, if the gear in the layer shaft moves in this direction, that is in the clockwise direction, so if you place an idle gear over here, it will also move in the clockwise direction. So as it will move in the clockwise direction, there is another shaft provided, that is the main shaft, that is the first gear, is provided. So what happens, the first gear will move in this direction, that is the clockwise direction. So whatever power has been this direction is maintained over here with the help of the idle gear. So that means whatever in this case, in the first case, whatever direction it's moved, the gear in the main shaft moves in the reverse direction. But in case of the reverse gear, what happened, it will move in the same direction or whatever gear, whatever power has been supplied to the lay shaft gear. So it is totally different from the other gears, that instead of pushing the car in the forward direction, it will cause the gear to move in the reverse direction but in the first gear condition, because the first gear is moved, and it is connected with, there. So what happened, so it will move like this, it will come like this and it will move in the first gear. So the reverse gearing operation will take place, but in the same way, but in the first gear, due to the place of the idle gear. Now this is all about the sliding mesh gearbox. Now we should study a bit about the constant mesh gearbox. Now here we come to the discussion of the constant mesh gearbox. In the constant mesh gearbox, you could see the diagram, the same diagram of the sliding mesh gearbox. The clutch gear is there, the clutch gear is there, and it is the clutch shaft. You could see the clutch gear and the clutch shaft, and over here are connected all the gears on the lay shaft, and all the gears are of the top gear and the first gear and the reverse gears are connected in the main shaft. Now here an interesting phenomenon you could observe is that all the difference in the sliding mesh gearbox, here all the gears are in the mesh condition, and all the gears of the main shaft and all the gears of the main shaft are, as they are splined, they are free to move, they are free to slide, and they are in constant mesh with the corresponding gears of the lay shaft. So therefore all the motions are taking place, all the gears are moving. Now here an additional dog clutch is provided. Now this dog clutch, what the dog clutch does, basically the function of the dog clutch is that the dog, as it is fitted on the spline shaft, so it could move left and right depending upon the requirement. So you could see that here what happened, as all the gears on the main shaft are splined, so that it could move freely, but the gears on the lay shaft are fixed, and it can't move freely. Now what happens when power flows? What happened? The power flows from the clutch from the clutch shaft, from the clutch gear to the lay shaft gear. What happens when the dog clutch moves to the left? If you see that when the dog clutch moves to the left, the dog clutch can slide. When the dog clutch can move to the left, the dog clutch gears are in mesh with the gear of the gear with the clutch gear, and we get a direct drive, that is the top speed. Now when the dog clutch is moved to the right, as all is moving, now when the dog clutch is moved to the right, what happens? The dog clutch is just connected with the dog clutch is connected with the second gear. Here the lower gear, here the dog clutch is connected with the second gear. The dog clutch is connected with the second gear, and what happened, now the power moves, and now the power comes over here. The first case it moves direct power transmission, and when the dog clutch is connected, it moves in the right. What happened? Power then moves from here, it goes like this, and it moves like this, and it moves in this direction. So what happens when the dog clutch moves in the right? It is connected to the second, it is engaged with the second gear, and the power moves like this. Now what happened when the dog clutch of the second dog clutch, when the second dog clutch moves to the left, what happens? The second gear, when the second dog clutch is moved to the left, what happens? Now the power moves to the second lower gear. Now the power comes over here, and as dog clutch is connected with the left, is engaged to the left. Now the power moves in this direction. Now the power moves to the help of the lower gear. Now when this dog clutch, when the second dog clutch moves to the right, it is engaged with the reverse gear. Now when the second clutch moves to the right, it is engaged with the reverse gear, and the power moves like this, Now this is the example of the constant mesh gearbox. Now it has certainly has an advantage slower in comparison to that of the in comparison to the sliding mesh gearbox, because as the first advantage is that as the gears have to remain always in mesh, it is no longer necessary to use straight spar gear. Instead, helical gears are used, which are quieter in running, which does not make noise in running. A second advantage is that wear of dog teeth on account of engaging and disengaging is reduced, because all the gears of the dog clutch are involved compared to only two or three in case of the sliding gears. So here all the gears are engaged, but here the mechanism moves by the shifting of the dog clutch. Here all the gears are engaged. So what happened? The wear is reduced, and we could go for the option for the helical gear, which is which are much quieter in comparison to the spar gear, And the second one is that as all the gears are enmeshed, so that is the engagement of the teeth and disengagement of the teeth every time causes a damage in the teeth surface. So this is not occurred because all the gears are in constant mesh. Here only we have to shift the dog clutch. When we shift the dog clutch in the left, we will get a direct drive as we have shown, and when we move the first dog clutch in the second position, we will get a second drive. And in the same case, the second dog clutch when moved in the left direction, what happens? We get a lower gear drive, and when the second dog clutch is moved in the right direction, we get a reverse gear. So this is all about the two types of gears we have discussed. The first one is the constant mesh gearbox, and so the first one is the sliding mesh gearbox, and second one is the constant mesh gearbox. Now, if you really like my lecture, if you way of delivering my lecture, so you can put a thumb mark to it, and you can keep updated to my channel for more videos. So if you require, you can subscribe to my channel. Thank you. Have a nice day.